Okay, homework 9, number 8. In this problem, you're asked to write a while loop that prints the square root of the first 25 odd positive integers. Okay, so I need to do two things. Find out the first 25 odd positive integers and then find out the square root of all of these numbers. Let's go to MATLAB and work on this. So I'm opening a new script, and again, it's homework 9, problem number 8, and I want to write a while loop that prints the square root of the first 25 odd positive integers. And you could do it two ways, right? I could just say I is equal to 1 and then while. So this will be the counter. So I need two counters. Counter for the loop, right? And then I need another counter. I'm going to say odd is equal to 1 or 0 in this case. And this is the counter for the odd numbers, right? So I could do it this way. Then I could say while odd is less than or equal to 25. If remainder of I by 2 is equal to 1, odd is equal to odd plus 1, and I equals I plus 1. Right, so let's go through what I did here. So I have two counters. I is the counter for the loop, and this will count the numbers 1, 2, 3, 4, 5, 6, all of the numbers, whether they're odd or even. It's not going to discriminate. And then odd is the counter for the odd numbers, because what I want to achieve here is I want to find out the first 25 odd positive numbers, and then I also want to find out the square root of these numbers, right? So in the while loop, my logical expression, while the number of odd positive numbers less than 25, I'm gonna, so as long as I did not reach my first 25 odd positive integers, I'm gonna check every number if it's odd. So if the division of I by 2 is equal to 1, so this is a logical expression to determine the odd numbers, then odd is equal to odd plus 1, and I also need to print out the square root. So I'm going to print out the square root of I as well, and then I'm going to increment I. So if you think about it and we go through our iterations, so let's try and figure out the iteration. Iteration 1, I is equal to 1, odd is equal to 0. These are the initial conditions. Is odd less than 25? Is 0 less than or equal to 25? The answer is yes. Now go into the if statement. If remainder of 1 comma 2, is it equal to 1? The answer is yes, because 1 divided by 2 is equal to 0, remainder 1. So I'm going to print out square root of 1, and now odd becomes 1, right? Odd becomes 1. Let's just tighten this up here. Okay, now odd is equal to 1, and then it's going to exit the if, and now I becomes I plus 1, I becomes 2, right? And then similarly for iteration 2, in this case I is equal to 2, odd is equal to 1 initially. Is 1 less than or equal to 25? The answer is yes. Now if is rem 2 comma 2 equal to 1, 2 divided by 2, my remainder is 0, is not 1, so this is no. So it's gonna exit the if and go back to the while loop. Iteration 3, now I is equal to 3. It's gonna exit the if, and then it's gonna, so in iteration 2, after exiting the if, it's gonna increment my I by 1. So I now is equal to I plus 1, which is 2 plus 1 is equal to 2 plus 1, which is 3. right? Now iteration 3, I is equal to 3, odd is equal to 1. Is 1 less than or equal to 25? The answer is yes. Now it's going to check the remainder in the if the remainder of 3 by 2 is equal to 1. Yes, that's true. 3 divided by 2 is equal to 1, remainder 1. Then it's going to calculate square root of 3, and it's going to increase odd from 1 to 2. And it's also, after exiting the if loop, it's going to increase I from 3 to 4, right? 3 plus 1 equals 4. And it's going to do this until it reaches the 25th odd positive integer. So this loop should achieve what we want. So I can write CLC clear, just for good housekeeping, and if I run it, I'm going to see the desired output here. So you can see that you have the 25 numbers, which are the square root of the first 25 odd positive integers. And we can check it, so I could take this number 7.1414 squared is equal to 51, so it makes sense. 51 is the 25th odd positive number. Okay, so this code will achieve this. Alternatively, you could do something else. So what you could do is, instead of checking every time if a number is odd or even, you could just increment I by 2 every time, right? So if I is 1, 3, you can just go over 1, 3, 5, 7 by yourself without actually checking this. So in order to do this, I'm going to say while I is equal to 1, and in this case, I'm going to have a counter here, right? Counter, let's call this also 1. So I'm going to say while counter is less than or equal to 25, I is equal to I plus 2 and square root of I. So what this does is I have a counter, just again it's for the odd numbers. So while my odd number is less than or equal to 25, I'm taking the square root of I, and then I'm incrementing I by 2 to just move to the next odd number, right? And this will achieve the same sort of thing without having to check whether it's odd or even using the REM function every time. So if I run this, I'm having an infinite loop here, so we did something wrong. Let's have a look. Yes, so what we did is we forgot to increment our expression in our counter in the logical expression. So I need to say counter is equal to counter plus 1 so that it stops. Otherwise, I'm going to have an infinite loop. Let me run it again. And here we go. So we're able to reach this. But logically here, we have a flaw, because what we're doing is it reached only to 49 and not 51. So let's see what counter is. So counter is 26. So it went 1, 2, 3. So it was able to run this loop 26 times and then exit on the 26th time. So we have two things. Let's try and figure out what the 25th odd positive integer is first. We're trying to troubleshoot what's going on here. So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 7, 29, 31, 33, 35, 37, 39, 41, 43, 45, 47, 49, 51. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So my 25th odd positive number is actually 49. So this loop achieves this very well. whereas our previous loop did not. So let's go back to our previous loop and try and troubleshoot why it did not, or our previous logic. So in our previous logic, I was using while I, or while odd is less than or equal to 25, and I had odd is equal to 0. Right, let me comment these guys. Then I was checking if rem of I comma 2 is equal to 1, then square root of I, and then we said odd is equal to odd plus 1, and in our previous logic we had I equals I plus 1, and then you end that with that. So if I run this loop, I'm going to end up at 51, which is the 26th odd positive integer. And the reason is we start with I equals 1, but we initialize our odd to 0. So this is the discrepancy. This is what caused us to go over our desired computation by 1. And the reason is that the reason is that 1 is actually an odd number. So at the beginning of the loop, our odd has to be equal to 1 because we start I at 1. Okay, so this is difference in the logic. That's why we had a small logical flaw in the first approach. So try it, think about it, and come to office hours or to the SI help sessions if you have any questions.